All right, section 1.4, this is question number 5a. It says, what's the value of the first term for each geometric series described? So we're looking for t of 1, right? The value of the first term. So what are we given, and how do we use that given information to use maybe a formula or an equation to solve? So what do we have? Express your answers to the nearest tenth if necessary. Okay, fine. So we can use decimal places. You don't have to worry about fractions necessarily. So the value of the first term. So I'm given a sum of 33. So S of n is 33. That's great. T of n is 48. And R is negative 2. Okay, so I'm given these three things. Can I solve for T1? Well, I guess what we have to consider are what are the formulas that we have to work with. So it's geometric sum formulas. So it looks like we're going to be looking at one of these two. Okay, so can I, and let me see if I can copy this here. Let's copy these and bring them over to where we're working, which would be, 1.4, right. And, okay, give me 1 second here. 1.4, number 5. There we are. So let's drop these formulas right here. Bring them over. Technology, isn't it great? Okay, I get to see my world here. All right, so one of these sum formulas. Let's see, can we use one of these sum formulas? Well, is there a sum formula that involves S of n, T of n, R, and T of 1 only? Let's see, S of n, T of 1, R. Ooh, we don't have n. Do we have n? No, we don't have n. Okay, so what about this one? S of n, R, T of n. We have T of n. We have R. We're looking for T of 1. We have R. Oh, I think this is the one we want to use because we have everything except for T of 1, which is what we're trying to find. All right. So let's use this one over here, and I'm going to put 33 as S of n. Got that. Equals R. We have that. Negative 2 times T of n is 48 minus T of 1. Okay, so that's unknown. That's what we're trying to find. We don't know that. So we'll leave that just as T of 1 in the equation. Divided by R minus 1, so negative 2 minus 1. Okay, so now we just simplify for T of 1. We have to isolate T of 1. So let's do a couple steps together here at once. So we can do, this is going to be negative 3 down here. If I multiply negative 3 both sides, that's like multiplying this by negative 3, and then this is gone, right? So that's going to be negative what? Negative 99. And what's this? 2 times 48 is negative 96. Okay, minus T1. Is everyone okay with that, what I just did there? Okay, so if we add 96 to both sides, I get negative 3 equals negative T1. And of course, divide both sides by negative 1, I get 3 equals positive T1. So, so you want to double check my work there? Does that sound like the answer? Those of you that did 4.8 got the answer? Okay. All right, so just again, check what you're given. Look at a formula and see if you can use one of those formulas to solve for the unknown. Okay, so we take a look at number 6 as well here. The sum is 4372 for this geometric sequence or series. Now, is it geometric? I guess 4 times 3 times 3 times 3. Yep, it's geometric. And we know that R is 3. Okay, that's what we multiply each term by to get the next term. So how many terms are there? We're actually looking for n here. We don't know what n is. That would give us how many terms. So let's see. We have the sum. We have R. We have T of 1 listed here. So sum, R, T of 1. Is there any way we can solve for n? Well, here's the sum formula where n is just a variable by itself. This n, you can't solve for this n because this is attached to T of n, so that you can't use this one. Have to use this one. So n is in the exponent position. So for you guys right now, you don't really know how to use logarithms to solve for unknowns in the exponent position. So we're just basically going to have to just kind of trial and error or intuitive sort of guessing there. But let's set this up. So we've got 4372. That's going to go here. T of 1 is 4. So 4 times R to the power of n. So R is 3 to the power of n is unknown, so let's leave that as n, minus 1, all over R minus 1. That's 3 minus 1. So this is excellent. We've got everything filled out except for the variable that we want to solve for. So it shouldn't be a problem. So 3 minus 1 is 2 down here. Let's get rid of the 2 from the denominator by multiplying both sides by 2. So what's this going to be? 8744? 8744. Somebody check my mental math there.
We're dividing.
80, wait, what? 8744. Is that what I said? 8740. Anyways, what's this times 2? I'm multiplying this times 2. It's 87. Oh, I wrote it wrong again. 8744.
Yeah.
What did I write the first time? I wrote 8744 the first time? Oh, 8477. I'm not very good with numbers, sorry. Yeah, using a calculator would be great, but it's a lot of work to use this calculator sometimes. It is. It takes a lot more time. Calculators are a waste of time sometimes.
Not really.
What's 1 plus 1?
2.
No, use your calculator.
I do that.
Yeah, waste of time. Look at you can't. It's 7 seconds. You did see calculator waste of time.
Not at all.
Point proven.
No.
One for the teacher.
What if you're wrong? What if 1 plus 1 isn't 2?
It's so true. She has a point.
Okay, so if 1 plus 1, your guess being 2, if that's wrong at this level,
Verify.
you have a problem. Okay, let's continue. No, you do have a problem if 1 plus, you can't get 1 plus 1. Ah, okay. As I was saying,
Not wrong.
look at this 4. Now we're wasting time, that's for sure. Let's divide by 4, and I'm left with 3 to the power of n minus 1. So 8744 divided by 4,
I use my calculator.
2186. 2186, is that what you said? I believe that. Equals, oh, let's add 1. Add 1 equals 3 to the power of n. Okay, so someone on your calculator, please do 2186 plus 1. 2187 equals 3 to the power of n. Now, at this point, like I said, if you know how to use logarithms, which I don't think you really learned this, right? You can. I can show you here real quick. It's not a big deal. But at this point, you'd basically just trial and error. You would guess and check using your intuition. So it's not going to be 3 to the power of 3. It's probably going to be something more like 3 to the power of 23 maybe, or probably not that high, 3 to the power of 12. You'd just check a few. Now, if you wanted to, I'll give you a little tip here. If you wanted to find out what n actually was, you would have to do this. Are you ready? You'd have to take the logarithm of both sides. Logarithm of both sides. There's a property of logarithms that says that this exponent can come down as a multiplier. So then you divide both sides by log of 3, and you get log of 2187 divided by logarithm of 3 equals n. That's the way you use logarithms to solve for a variable in the exponent position. But at this point, it's probably going to be just as effective if you just kind of guess and check. So let's try that. Okay, so if you use the logarithms, you get an answer of 7 for n, and of course 3 to the power of 7 is 2187. So it's not 3, it's not 21, it's not 12, it's 7. So n equals 7. So going back to the question, how many terms are in the series? 7. 1, 2, 3, 4, and then 5, 6, and 7. Boom, you got your sum. That's 6. Okay, so yeah, I've had some students ask me, how do I find n here? Well, you can't multiply, divide, add, or subtract to solve for an unknown variable in the exponent position. Instead, what you have to do is either guess and check or use logarithms, which we will study more in future classes. Actually, even in this course, I think, but just later chapter. Okay, any other questions about what I do, 5 and 6? 5 and 6 there?
No, sir.
You good?